Today we're going to talk about taping measurements and correction factors. We did a taping exercise and we used the fiberglass tape. The following information is actually for steel tapes, but we're going to apply it to the fiberglass tape exercise. Now, when you get a tape from the manufacturer, he's going to have some standard conditions under which the tape was tested and calibrated. Sometimes the tape can actually have an incorrect length that it was calibrated to. For example, the calibrated length is 100.02, but it's supposed to have a nominal length of 100 foot or whatever meters. Now, it also was tested under a typical temperature. Now, that typical standard temperature was 68 degrees. Anything other than 68 degrees when tested or when used is going to need to be corrected for. You also have a tension or a pull correction. That means when it was tested, it had a standard tension applied to it of 12 pounds. If we use more or less than 12 pounds, we'll have to correct for tension. And the last correction is for sag. When it was tested, it had absolutely no sag in it. So when gravity occurs and we have any drop in the tape, we'll have to correct for sag. Now, this information down here is the standard coefficients from the tape manufacturer, and we'll use those throughout this exercise. For the first one, we're going to assume that we have an incorrect length, that it was calibrated from the manufacturer at 100.02 feet. So we're going to use this equation. Correction for length is equal to the calibrated length minus the nominal length divided by the nominal length times the length that we actually measured out in the field. So here we go. Here's our setup of our equation. We're going to take the calibrated length, and it was assumed to be 100.02 feet. The nominal length of the tape was supposed to be 100 feet. So we're going to divide that by 100 feet, and then we're going to multiply it by the distance measured out in the field, the 321.56 feet. So that's going to give us a positive 0.06431 feet. That's the correction for length. For correction of temperature, we're going to use this equation right here. So the correction of temperature is the K, which is a coefficient of expansion or contraction of steel. Remember, we're using steel, but we're going to apply it to a fiberglass tape, multiplied by the difference between the temperature that we were outside during the measurement minus the standard temperature times the actual length measured in the field. So here we go. Our K coefficient is going to be the 0.0000065 per unit length per foot or per Fahrenheit. The temperature out in the field was 68 degrees. So there's our K coefficient. Out in the field it was 83 degrees and the standard temperature was 68 degrees. We're going to multiply that by 321.56 feet, and that's going to give us a positive 0.0313521 feet. Now we're going to be rounding these off at the very end. We're going to keep accumulating our values past the decimal place by several decimal or by several place units. Now the next one is tension or pull correction. The equation is for correction of pull is equal to the pull that was applied out in the field during the time that we measured minus the standard that was completed at the manufacturer multiplied by the actual measured distance divided by the cross-sectional area of the tape multiplied by the modulus of elasticity of the steel. So here's how it works. We had 15 pounds of pull out in the field. The standard was 12 pounds from the manufacturer. The measurement out in the field was 321.56 feet. All that divided by the cross-sectional area, which is assumed 0.005 inches squared, multiplied by the modulus of elasticity of steel, which was 29 million pounds per square inch. And that's going to equal 0.00665 feet. That's our correction factor for pull. The last one has to do with correction factor of sag. In this one, we're going to use the equation correction factor of sag is equal to a negative unit weight of the tape in pounds per foot squared times the length that we measured out in the field cubed divided by 24 times the tension that we actually pulled out in the field squared. So here's how it goes. We have a negative unit weight of 0.01 squared times the length measured out in the field, the 321.56 cubed, divided by 24, divided by 15 pounds squared. That is going to give us a negative 0.6157 feet. Now, all these corrections have to be taken into for a total correction. So we're going to get a corrected length of L. So L prime is our measured distance. Our CL is our correction for length. CT is correction for temperature. CP is correction for pull. And CS is correction for sag. We're going to add all those values together. So it's going to be L is equal to 321.56 plus 0.064 plus 0.31 plus 0.007 minus 0.6157. That is going to give us a corrected length of 321.0463. But we're going to round off only to 2 decimal places. So our length is going to be 321.05 feet. And that's how we're going to, that is it for now. And if you have any questions, just come see me in my office during office hours. Thanks.